Right, things will get clear when we do the example, right? So let us do this example. Find the integral 0 to 3 2 dx. That means this is the definite integral because we have the value, right? So 0 to 2 dx using limit definition. Basically what it is asking, if you want to see the figure, then look at this. This is x-axis and y-axis, right? So the function is 2, so it is the function, okay? And you want to see between 0 to 3. So basically you want to find out this area. You see that? You are trying to find out this area because it is f of x equals to 2. So you are trying to find out the area between 0 to 3 under the curve fx equals to 2. Now, but you want to use the limit definition, okay? So how do I use the limit definition to find out that? So let me recall the formula. We know that the Riemann sum or 0 a to b f of x dx, the definite integral between a and b under the function fx is given as limit norm tends to 0. Norm tends to 0 meaning we will divide this into so many subintervals, right? But the subintervals may not be of the equal width. Some of the subinterval may be big, some of the subinterval may be small. And then if we take the width of the biggest subinterval tends to 0, meaning when the biggest tends to 0, biggest is very small, then all the other will be very small. In that case, the definite integral or the area under the function between a and b is given by limit delta tends to 0 summation I runs from 1 through n, okay? And then what we do is f of ci times delta xi. But I think in the at the beginning I forgot to write down what is the formula for ci, where ci is given as a plus I times delta x, okay? And then delta xi, you can say delta xi. And then what is delta xi? Delta xi is b minus a over n. This is what you use to find out that ci and delta xi. And then we just plug in those values, okay? So delta xi, you can write delta xi or just delta x for the ci, but we use exactly the same value to find out ci there, okay? So let us do this. So how does that look like then? So solution is, so what is f of x in our problem? F of x is just 2. What is a? A is 0. What is b? B is 3, right? So what is delta xi then? Delta xi is 3 minus a over 3 minus 0 over n, that is basically 3 over n. You see that? And what is ci then? Ci is a is 0 plus I times delta x is basically 3 over n. Basically this is ci is 3I over n. You see that? Now what we do is you use that formula, okay? Therefore the definite integral 0 to 3 let me write down fx first for now, and then we will do that. F of x dx is same as limit norm tends to 0, norm, the biggest norm tends to 0, summation I runs from 1 through n, and then f of ci times delta xi. This is the formula, right? So how do I write that? Because when norm of delta tends to 0, what does that mean? The width of the biggest subinterval tends to 0, then you will need so many subintervals there, right? So many subinterval means the n is the number of subintervals. N is the number of subintervals. Subintervals. So when delta tends to 0, don't get confused about delta xi and delta. Delta xi is the width of these subintervals, and norm of delta is the biggest width of the subinterval, or the width of the biggest subinterval, okay? And n is the number of subinterval. In this case, when the biggest subinterval has width 0, you will need so many of the subintervals, that is n tends to infinity. So you can write limit n tends to infinity, right? And summation I runs from 1 through n. What is f of ci? So ci is 3I over n. I am going to write f of 3I over n times what is delta xi? Delta xi is 3 over n. You see that? Now, what is f of x? F of x is 2. Whatever value of x you take, it is always 2. That's what it says, right? That's what the f of x equals to 2 means. So let me write down that limit n tends to infinity, summation I runs from 1 through n. This is just 2, right? And then what is that? That is 3 over n. 3 over n. You see that? So how much is that? This is basically 6 over n, right? So this is basically summation I runs from 1 through n. It is 6 over n. Okay? So what do you get? So this is basically limit n tends to infinity. So what is the summation of 6 over n? There is no I there, right? If there was I, you need to use the sum formula for that I. So what is that? So let me write down that summation of 1 I runs from 1 through n. C is just C times n, right? Because if there is no I, it is just, you can pull that C out, and then that is just adding the 1 n times. You can think 6 over n is there, and then summation I runs from 1 through n, and then 1. You are adding 1 n times, right? It is like that. So how much is that? So it is limit n tends to infinity, right? And then 6 over n is there. So sum of the i's, sum of the 1 n times. If you add 1 n times, it is just n, right? So you can cancel, basically. You can cancel that n and n. So you don't need limit anymore because there is no n left, right? So what is the final answer? It is just 6. So area under fx equals to 2 between 0 and 3 is basically 6. Okay. So there is another shortcut way. You will see that in the next section, section 4.3. But for now, we know only the finding the limit, or finding the definite integral, or area under the function between two numbers. This is the only way that we know so far.